Hey guys, and welcome back to UnicoDev. Now, I know it's been a while, but I got something really exciting to show you. Basically, I found a virus in the wild. And yeah, you can just open this file, and this is actually a computer virus. Now, we're gonna dissect what it does. Obviously, I strongly suggest you to not put this on your computer. I'm gonna explain briefly how I came across this file, and what you should do when this happens, and what you shouldn't do, which is what I've done. And yeah, we're gonna just have some fun and look at what this does to your system. Let's begin with how I found it. It's pretty funny actually. So my mother teaches in a middle school, and you know how middle school computers have like zero security and they're riddled with viruses for some reason? She decided to plug a USB into this computer because she just wanted to show some slides to the students. Now that was a really pesky mistake, because once my mom came back home and showed me the USB, we found it in this state. So basically there was this empty folder, okay, with all of the files. So right now it's empty, but imagine that here there are like the normal slides and files on a normal USB, and they were hidden away in this empty folder that was also hidden from the user. So it was like a hidden file. And then there was this pesky file that doesn't look suspicious at all, that is called explorer.ps1. Now, I feel like what the attacker and hacker wanted to happen was that when you click on this file, thinking that it will open the Explorer to actually see the USB and all of the contents, you will actually execute a script, and that script is gonna do like some malware and some bad stuff to your computer. Now, what exactly is a PS1 file? A PS1 file is a PowerShell script. So this means that it's gonna execute some code on a Windows terminal. Now, luckily I'm on a Mac, so this code wouldn't have, worked for me, and I wouldn't even have been able to run this virus, but this means that I can basically dissect the code and actually see what it does. Now, I strongly suggest you not to do this unless you are on a virtualized environment or you're 100% sure that you know what you're doing and the code is actually, safe. Alright, so let's get started. First of all, what is in this file? Well, a bunch of code. So this is basically the code in the file. Now, PowerShell code can be divided by lines with a semicolon. So the first thing I did was basically just find all of the semicolons and just, press enter and divide the code this way. And now you might be saying, Nico, what are all of these files right here? Didn't you just find one file? Now, this is the thing with viruses. In order to circumvent the antivirus and all of the different software you put together and your operative system puts together to actually, detect the virus and fight it, they will actually do a bunch of shitty stuff, like encoding the code in different formats, so the antivirus cannot see it. So this code may seem pretty harmless, it's just a few lines of code, it's just literally 2 lines of code. But basically what this is doing is taking all of this content, which is basically a string, okay, and it's putting it into a variable. And then it's using this invoke expression method to execute the content of this variable. So all of this string here can be interpreted as a base64 string, and this is actually some hidden code that will then be invoked by this line. So basically what this line is doing is basically executing an entire new script, almost. So it looks pretty harmless, but no, this could actually be anything. And now let's actually find out what this is. Now you can use any programming language to decode base64, you can even run a simple Python script and there is a method to decode base64 to a normal string, but just for simplicity's sake, I'm gonna use something online for this. So I just have a base64 decoder and I'm just gonna paste the string and it's gonna decode it into a human readable format. As you can see, it's pretty gibberish. Now I'm not 100% sure why this is happening. If somebody knows in the comment, you guys can let me know, but if you decode every other line, you will see some code appearing. So then what you can do is just paste this line right here, and this is pretty funny, and remove all of the non-ASCII characters. Probably shouldn't have done that, okay. So just to reiterate, I took all of this code right here that is getting executed by the machine because of this second line, which I lost, because of this second line right here. And now I'm dissecting this code and, trying to understand what exactly it does to my computer. Probably nothing good. So now this is the new code I found, and now it will get a little bit more complicated. Okay, so I zoomed in a bit so you guys can see. So basically this code is also some code that is doing nothing, it's just deciphering the next bit of code. Yeah, we need a lot of protection from people like me that try to read exactly what this virus is doing, so we need to add some more protection to the code so we don't know exactly what it's doing. So right now we have another base64 string, and we might say, okay, well, I already did this before, this is easy, I just need to decode this. So let's go to the same website and let's decode it, and oh, it's gibberish, it's complete gibberish. There is no way that this can be interpreted as some code. So are we stuck? Is this it? Well, we just have to read the code before and see exactly what it's doing. Now, this string actually represents some code, but there is some bad news. This code is encrypted. It is actually encrypted using the AES encryption, which, if you know, did optimally, it's actually really secure. It's actually the basis of, you know, all of the encryption on websites and stuff like that, so, you know, it's actually secure. So if there are no flaws with this code, you shouldn't be able to decrypt this code. So in that sense, our journey would end here. Well, the good news is that this video is not 5 minutes long, so our journey didn't end here, but still, this is a really strong encryption. But you know what's really strong about an encryption? You know, the encryption method, the algorithm, which I'm not gonna explain in this video, but you can find other related videos in the description that explain exactly how encryption works. But what's really strong about the encryption is the encryption key. And also keep in mind, all of this is to decrypt this code. So there is this code that is running on a machine that before running needs to be decoded first. Because as you can see, these bytes that represent the code, at the end of all of the, you know, journey, they actually get decrypted, and the decrypted data gets invoked as a function. So it's the code that will be executed next. Now let's go to the key. The key is actually a hash 256. Now what this means is that the key is 256 bit long. Well, let's do some maths, okay? We need to try every single combination, okay? And every bit can be either on or off, so it can be in two states, okay? And every single bit can be one on or off, independent from the other bits. So we have 256 bits that can be in all combinations of on and off. So we have to do 2 by 2 multiplied by 2 by 2, 256 times. So it's 2 elevated to the 256 power, which is a really high number. There is no way we're gonna brute force all of this. You can find some videos on the internet that like compare this number to like the number of seconds in the universe and the number of stars and the stars containing other universes inside of them. It's an insanely big number. I'm actually gonna leave, you know, some funny content about this in the description. So okay, is our journey finished here? Well, no, because this key is not randomly generated. If this key were to be randomly generated, we would like not even the Windows computer, not even the computer would be able to decode this code. This key is actually generated with some logic. And what exactly is this logic? Okay, it's a really convoluted logic and hard to understand. So basically I'm gonna try to explain it as best as I can. It's actually not that complicated, but you know, the way the code is displayed right here is super convoluted. Alright, so let's suppose we have some input, okay, like hello, okay, or hey. Okay, we have this input right here. What we want to do is we want to translate this input in a fixed length string. So we want a string that is an exactly the same length. In this case, the string is gonna be composed of 256 bits. So we are gonna just translate this string into a string that is just 256 different ones and zeros, okay? So we want to translate this. How do we do this? With an hash function, okay? So basically what this thing does, what the hash function does is it takes some input and translates it into this. Now the very cool thing about the hash function is, if we don't know what the original input is, from the output we cannot go back to the input. So this is not, how do I change the color? I know I'm using like online paint for this. This is not a possible operation without brute forcing every single possible input. So basically this is the gist of the hash function. Naturally, if we give the hash function the same input, we are gonna get the same result. But if we give the hash function a slightly different input, like hey, and then, I don't know, we add a number, okay, or we add anything, or we change any letter, we're gonna get a completely different result. We're not gonna get a slightly changed result. No, it's gonna be completely different. So basically, this is the main property of the hash function, and this is why it's really secure. You can take anything, like a password, and translate it into this hash. So, you know, it's gonna be really hard, and mathematically, let's say, computationally impossible to crack back if you only know the hash. But in this case, we don't only know the hash, we also know how this hash is generated, so we know some of the input. And let's see how exactly it is generated. So in order to generate the hash, we are taking this string right here as input. So we're opening a terminal shell, basically this CMD opens a terminal, okay? And we are executing this command right here, vol, okay? So we are taking this output of the command, we are splitting it in different lines, so basically the split command takes every single line, and then we are taking the last line basically, and then we're trimming it, so we are removing any, you know, spaces that remain. And that is the input of our hash. And you might say, Nico, what did you just say? This doesn't make any sense. What does this command even do? How can I even understand this? Now, unfortunately, I'm not on a Windows computer. I could emulate it, but, you know, it's not worth it. What we can do is, online, we can also find a Windows console emulator, so we can test this command out. Or, you know, we could even read the documentation, but would read those anyway. We get that this command is not recognized. Okay, well, I give up, let's read the documentation. So this is the example of a vol command. As you can see, we're gonna get some information about the current drive we are in. So it's gonna tell you volume in drive C has no label, volume serial number is... Haha, okay, so the last thing that we get is the serial number of the computer. So what does this mean? This means that we are taking this string right here, volume serial number is, and like some data, okay? And we are taking this string right here, we are dividing it in lines, so we are only taking the last line, and we are trimming everything but the last space. So what does this hash actually, you know, get inputted? What's the input that generates this hash? It's basically the serial number of the computer. And now, why is this a thing? I don't know. Maybe the person that planted this virus, or probably the website where this virus got downloaded from, knew about the serial number of the computer, or, you know, the computer has an even bigger virus that basically duplicates on USBs, and it can only be decoded by the same computer, because only that computer knows about its own serial number. Now, if I run this vol command on my computer, this serial number is gonna be different, so I'm not gonna be able to retrieve the content of this code. Now, naturally, if I wanted to, I could sneakily go to my school computer. I mean, I also informed them that they had a virus, but I could also go there and just do this command on my own and retrieve the serial number of the computer, but that would be no fun, okay? That's really easy. So I can just get the serial number, and then instead of putting all of this junk right here, I change this line to basically this line, to this line with the serial number that could be, I don't know, anything, so just something like this. And now I can execute this code, and I will be able to decode finally this code. Now, let's suppose I don't have access to this computer. I just found a virus in the wild, and I have no idea what computer it belonged to. How can I do this? Am I stuck? Is it hard to, you know, brute force the serial numbers? Well, it is complicated, but it's not as hard as brute forcing a 256-bit string, because serial numbers are much more limited. So by reading some documentation, or, you know, just asking ChatGPT, we can get the format of the command, which is a 32-bit hexadecimal number. So this means that instead of 2 to the 256 possibilities, we have 2 to the, let me do some calculations, some quick maths. We have 2 to the 32 possibilities, which are still a lot. It's like 4 billions, I think. Yeah, it's around 4 billions, but it's possible, okay? If we try every possibility, like every millisecond or something like that, we can actually get the solution in a few days, or yeah, probably a couple of days. So what we can do next is, you know, write or ask ChatGPT at this point to write some code. He actually, you know, didn't want to do this because he thought that it wasn't possible, but I told him, no, look at this, it's impossible. It's not a 256 key, it's actually a 32-bit number. So he wrote me some code which is the exact same code as this, but instead of using, you know, this, you know, hash right here, it's gonna basically try every single combination, and it gave me some suggestions and stuff like that, but at the end, he actually wrote this code that is actually gonna try every single key. Okay, so this is basically the code put into Visual Studio Code and in Python, and as you can see, we are going through every single combination, and we are getting the serial number correctly, and then we're trying to decrypt the data. If it doesn't work, it's gonna throw an exception, and it's gonna keep going. Once we find the correct serial number, then we will be able to see the decrypted data. And now I also tried to make this code run a little bit faster by making it threaded. So basically the main idea of this is, instead of doing one search at a time, we run multiple threads. So as you can see right here, I start different threads on my computer, on my processors, so that more code gets executed at the same time. Because I actually don't need the stuff to run sequentially, I could check every single serial number in different times. I don't need to do it sequentially, do the first one, then the second one. I basically divided all of the search into different threads, and based on some chunk size that I have assigned. So right now the chunk size is, basically the entire pool, because there is only one thread. But if I make this 5, for example, 5 different threads are gonna start, and they're basically gonna divide the entire range of stuff that I need to check for into, different smaller bits, and it's gonna run that code at the same time. In order to save the progress, it's also gonna write all of the code into a file that I don't think we have right now. Yeah, I think I deleted them, but basically it will write everything it already processed into a file, and maybe I can show you the file later. And at the beginning of the code, if we are running a batch that we have already processed, we are just gonna skip it. And in order not to spam the text with a bunch of different serial numbers, because there are literally 4 billion, we are gonna do this operation only once every million. So we're basically saving progress once every million serial numbers, and this is basically gonna be once every 20 seconds-ish. So this means that it takes 20 seconds to check 1 million serial numbers and to see if they work. And now if we do some quick maths, okay, let's do some quick maths again. We have around 4 billion, we divide it by 1 million, so 1 and then 0, 0, 0, 0, 0, 0. Yes, I think. Yeah, this should be correct. And now this is the number of 20 seconds, a number of batches it takes. And it takes 20 seconds to do each batch, so we do multiply this by 20, and this is the number of seconds it takes in the worst case scenario to actually, finish the search, and then we gotta divide by 60, so we get the minutes, and we divide by 60 again to get the hours, so it's around 23 hours. And I mean, consider I'm not gonna leave my computer open for 23 hours or 24 hours. I'm probably gonna just run this script while I'm doing other stuff at work. I actually set up a little routine that runs this script as soon as I boot up my computer, and it's gonna tell me when it's done. But yeah, I actually did this, and in not even a couple of days, in just half a day, it actually converged into a solution, because luckily the serial number was pretty low, or I mean not pretty low, but was probably at the beginning of one of these threads. So yeah, just to show you that this code works, I'm gonna run it in my terminal right here. So I'm gonna run Python, where is it? Where is the terminal? Oh, okay, there you go. It just opened 500 terminals for some reason. We can just do Python 3 and main.py. And as you can see, the code is gonna start running. Never mind, it's not gonna use the correct virtual environment. We have to do venv/python. Where are you? venv/python 3. And nope, no, still nope. Okay, there you go, it's gonna start running, and as you can see, it's gonna, start with every single serial number. Now, naturally, I'm recording, so this is probably gonna crush stuff, and it's gonna go much slower, but, when nothing else was happening in the background, it took 20 seconds to do 1 million serial numbers. And right now, it's not threaded, so it's doing one at a time, but as you can see, it did the first one, and now it started doing the first batch, and now in around 30 seconds, it's gonna get to the 1 million batch, and it's gonna keep going until it finds a solution. And as I said before, it's gonna save into this file all of the solutions it tried. So as you can see, it tried this batch, and then it's gonna try the next one, and so on and so forth. Yeah, as you can see, it's done with the first batch, so it wrote this one into the file. Okay, great, but let's stop this because we already found the solution, And once we decrypt the code with that solution, we get into a new file, and this is gonna be fun because, you know, the game has just begun. You thought that this was gonna be it, right? This was gonna be the actual code that we needed to read. Well, you were wrong. This is not the actual code that we need to read. This is more code to decrypt. Yeah, this is fun. But yeah, this is actually fun. The only thing is that it's really time consuming, but you know, it's worth it. So now this code is even more complicated. We got some more base 64 strings to decrypt, but these seem actually pretty straightforward to decrypt, so I'm just gonna do it right now. And bam. Oh, it looks like a website. Let's continue decrypting and let's see if we actually do get a website. Oh, it looks even more like a website. Oh, it's actually a website. And now I strongly suggest you not to go to this website. It's a WordPress website, so I don't know if there are like some, you know, possible flows into those websites or they are secure. But you know, stuff could happen if you go into that website. I went into the website with, you know, a remote machine, with like a virtual machine on a VPN just to check it out. And it looked like a really normal website with nothing sketchy going on. But now here is the thing. If you actually go to this website, and you actually execute some sneaky regex, this regex right here, in the website content, you are gonna find a secret, and that secret is gonna be a virus. Yeah, we would have thought. So what this code is doing is it's going to the website, okay, and it's basically executing a regex on the string, so on the HTML file that it gets returned to the website. So it's taking the web page and it's only filtering some data. What data is exactly filtering? I don't know. We're gonna go to the website and check it out, but not do it directly. Do it via a port or something that connects to the website and retrieves the information for us. So here is the page, and as you can see, it looks like a really normal page. I mean, we cannot really see much, but I also went on the page and it looks pretty normal, but there is something really scary about this page. And it's this div right here. I don't know if I can find it. So if we take all of this code and we put it into a regex 101, basically I put all of this code right here. This is the HTML page, and now we just insert this regex right here that is gonna get, you know, what we want. So we insert this regex right here, and as you can see, we are gonna get a match. And we need to go to the group 1, because as you can see, this guy is getting the second group. So right here, and this is the exact data that is the malware. So inside this code right here, a malware is hidden inside this web page, which is really interesting. Now, if I can find the malware, okay, there you go, found it. So right here, there is this, a commitment to innovation and sustainability, really fun. And then there is this div, which is hidden from view, so the user doesn't see it, that just contains some random malware, because why not? Let's just do this, it's fun. And yeah, what does this do? Well, if we go back here, and we actually decrypt this string using the same method we did before, so which we just advanced encryption standard, but this time we use as a key just the base 64 of this thing right here, which is just a constant, I think. So if we go here, yeah, this is just a constant, so we just use this as a key. I don't know why they added this little bit of security, like it's literally, it's not adding any security because we can just run this code on an emulator of PowerShell and it's just gonna work. But yeah, once we decrypt all of this and we get the new code, this is what we get. And yeah, wouldn't you know, we get some executable. Hooray, finally. Okay, now here comes the fun part. Basically, this code right here, which is the last code that we're gonna analyze, does the exact same thing that this code does. So it's basically gonna take your computer into a spooky web page, navigate to a web page, do a request, and this time the web page, instead of returning a string, the HTML, is actually gonna make the user download a spooky little file called runtimebroker.x. So if you actually decrypt this code, I'm gonna go faster because this is exactly the same thing as before, but if you actually decrypt this code right here, you are gonna go into this website right here. But now the funny thing about this website is that not only you actually go to the website, you also add some query parameters to, you know, your request, so that the attacker, the hacker, knows that, you know, its hack actually went through. So you're also gonna tell it that you are coming from the USB 1, which is pretty scary, and also you have a user ID that was assigned in the past Explorer. So as you can see, there is also this user ID right here. So, you know, this is really some really spooky stuff. And if you go to this website, which is blurred, but if you go here and you copy this and put it on your Chrome and you actually navigate to this website, you're gonna get back a virus. It's actually gonna download a binary, which is an executable that could do really a lot of harm to your computer. It could encrypt all of your files. It could, I don't know, it could sell all your data. It could be dormant and just, you know, mine some cryptocurrency in the background while you don't know, and might slow down your computer. It might do a bunch of bad stuff. Now you might say, well, Nico, why don't we go inside the binary and check out what exactly it's doing? Now remember at the beginning of the video when I said that, you know, this little adventure has a bitter ending? Well, the bitter ending is that unfortunately I went to this website, I tried a lot of query parameters and I tried a lot of different stuff, but I got nothing. So basically there is no binary in sight. I get no data, the website just refused to give me any data. In fact, the website returns a 404 error page, but I mean, you know, it could also give me a file, but it's not giving me any file. So this code right here, this virus, currently no longer works. Now what I think is happening is that somebody actually downloaded this file with this user ID and with this query parameter, and the PHP server in the background actually is noting on some database that this user already downloaded the virus and is not giving them the virus again. So because of this, there is no way for me to actually go further. Literally, this adventure is done. Like, I would need to find a computer that has the same virus but that didn't get open yet in order for me to actually go navigate to this website and you know, download the binary and examine it. But unfortunately, this is where our journey ends. Now, if you know somewhere this virus, I tried to find it on the internet in some databases. I didn't do some big research on it. I just, you know, looked some stuff up, but I couldn't find it anywhere. So if you guys know about this computer virus, it's pretty standard, and you know, you have more information, leave them in the comments. Naturally, don't, you know, leak stuff that you're not supposed to leak, but you know, just leave them in the comments, and if you have any way to actually find this so we can do a continuation video and actually analyze the binary, it would be really fun to use some software to, you know, analyze it. There are some really good softwares out there for white hackers to analyze binaries, like Ghidra, for example, and there are other tools that you can use to like do static analysis and even dynamic analysis. There is an entire world out there for this kind of stuff, and naturally to do them in a legal manner. I'm not condoning any of this for actually, you know, illegal activities. So, you know, a lot of, you know, content warnings on this, but you know, it might be really fun to actually go and continue this journey. But unfortunately, at this moment in time, the journey ends here. There is nothing more that I can do. I'm just stuck on this stupid URL that is not gonna return me anything. So yeah, this was the content for today. I hope you guys really enjoyed it. Leave a like if you did. And you know, I'm gonna read your comments if you guys are excited for more stuff like this. Now, naturally, it's really hard to do exactly this stuff, but maybe we can go read and learn about some more you know, virus hunting. We could find like some servers or some databases that already have known viruses or have known fake viruses, like challenges that you have to try to decrypt. I know some websites out there, and if I remember, I'm gonna leave some links in the description about them. So if you guys are interested about, you know, researching about this topic and learning more about how to you know, how all of this stuff works, I'm gonna leave some content in the description. But yeah, thank you ever so much for watching this video to the very end, and I'm gonna see you guys in the next one. See ya!